Hello everyone, this is Harrison Galway, and today I will be covering solving quadratic equations by completing the square. So for this technique, completing the square, we're going to go through a set of steps, and I'll show you what they are one by one using this example, and then we'll move on to a couple of practice problems. So the first step is we're going to take the constant term, which here is -3, and we're going to move it to the other side. So let's do that. Now we have 2x squared minus 12x equals 3 by adding 3 to both sides. Next, we need to make the leading coefficient 1 by dividing by a. So right now the leading coefficient of this quadratic is 2, which we call a. So to make it 1, I'll just divide both sides of the equation by 2. So I'll divide this all by 2 and I'll divide this by 2. And that'll give us x squared minus 6x equals 3/2. So I've made my leading coefficient 1. Next step is, and this is the key step, I'm going to add b over 2 squared to both sides of the equation. Now when we say b, we mean the linear coefficient, the coefficient multiplying the x to the first term, that's b. So here b is -6. So like we said, we need to add b over 2 squared to both sides. Let's take a second to compute that. b, which is -6, over 2 squared. Well, let's see, that gives us -3 squared, which is 9. So we're going to add 9 to both sides. So when we do that, we get x squared minus 6x plus 9 equals 3/2 plus 9. Okay. Now, the next step, we're going to do two things. On the left side, we're going to factor this trinomial that we have. Now, when you add b over 2 squared, which in this case was 9, you get something special. What we have here is called a perfect square trinomial. What that means is that it will factor into the same two factors twice. Now, you could factor this normally by figuring out what multiplies to the last term and adds to the middle, but there's a trick here. You don't even need to think about it. It'll always factor into b over 2, x plus b over 2, right? So again, b is that linear coefficient, -6. b over 2, that's -3, and that's what our factors are. It's just going to be x minus 3. And again, like I said, we get the same factor twice, so we can just say x minus 3 squared equals. Now let's take this right side and combine these two terms, right? We're going to need to add fractions, so let's do that over on the side. That's 3/2 plus, well, to get a common denominator, we need to do 18/2. That's the same as 9, so that gives us 21/2. So while we factor over here on the left, we'll combine like terms over here on the right. The next thing we do here is square root both sides. So I'll square root the left, square root the right. Let's show that. Square root the left, square root the right. Now when I square root the left, I just get x minus 3. When I square root the right side of the equation, you need to be really careful. Anytime you square root both sides of an equation, you have to put plus or minus. And we have root 21 over 2. Now, the next step I put here, this is kind of some, bookkeeping. We need to simplify the radical that we get on the right side. It may be that it's a perfect square, and you don't have to do that, but here we get this radical and there's a fraction inside of it, so let's simplify that. First thing we'll do is we'll rewrite this as root 21 over root 2. That's always true. The square root of x over y is the same thing as root x over root y, so we can do that. And then we'll rationalize the denominator here by multiplying the top and the bottom of this fraction by root 2. And that'll give us plus or minus root 42 over 2. The last step is isolate x. And to do that, we'll just add 3 to both sides of the equation. So we get x Oh, sorry, I think I want to be, well, that's fine. We get x equals, so we add 3, 3 plus or minus root 42 over 2, and that's it. Notice we got two solutions, 3 plus root 42 over 2 and 3 minus root 42 over 2. That makes sense. We started with a quadratic equation, or a second degree equation, so we should get two solutions. And that's it. That's how you complete the square. I'll do 3 examples now where I go through those steps, but it's always going to be the same steps. You might have to deal with imaginary or complex numbers, or more combining fractions, but ultimately, if you follow these steps, you'll get the answer. So let's look at these 3 examples. The first one, step 1, remember, is we're going to move the constant, -1, to the other side. So we'll add 1 to both sides, and we get this. Then we need to make the leading coefficient 1, but you'll notice the leading coefficient is already 1, so we can skip that step. The next step will be add b over 2 squared to both sides. And this is the key step, really, to completing the square. We have to add b over 2 squared to both sides. What is b? It's the linear coefficient, which in this case is 8, right? It's like a, b, c. So here b is 8. So we do 8 over 2 squared. That's 4 squared, which gives us 16. So we'll add 16 to both sides. X squared plus 8x plus 16 equals 1 plus 16. We can do that in our head. We get 17. Now on the left, we factor. And again, you don't really have to think hard about how this factors. It's always going to be just half of b, which is 4, right? So the factors are just x plus 4, x plus 4. So we can write x plus 4 squared. You can double check. 4 times 4 is 16. 4 plus 4 is 8. It checks out. And then over here, we still just have 17. Next step is square root both sides. And remember, it's really easy to forget this, but you need to put a plus or minus anytime you square root both sides of an equation. It takes a little while to remember that, but very important. Last step is isolate x. So we'll just subtract 4 from both sides. We get -4 plus or minus root 17, and done. On to the next one, number 2. Step 1, move the constant to the other side. So we have 3x, I'll use purple again, 3x squared minus 9x equals 2. Step 2, we need to make a, the leading coefficient, 1. And to do that, we'll just divide both sides by 3. Okay, so now we have x squared minus 3x equals 2/3. And we don't love fractions, but it is what it is. The next step, and the key step again, is we add b over 2 squared to both sides. A little inconvenient here because b is -3, which is odd. So when we divide it by 2, it won't divide nicely, but that's all right. So we have -3 over 2 squared, which is going to be, well, if we square a negative number, it's positive. And we'll just square the top, 9, square the bottom, 4. So we get 9/4. So we now have x squared minus 3x plus 9/4 equals 2/3 plus 9/4. Don't forget to add it to both sides so that the equation is still true. Now, let's do 2 things at once. On the left, we'll factor, right? And this would be a difficult problem to factor, just by staring at it. But remember, it always factors easily. It's just b over 2. Since b is -3, b over 2 is just -3/2. So our factors are x minus 3/2 and x minus 3/2. I'll just square that. Here we need a common denominator. So let's see if we can do that in our head. Common denominator is 12. So this is 8/12 plus 27/12. That's 35/12. I think I did that correctly. Let me just double check. Don't want to make a video with a mistake. So let's see, that's 8/12 plus 27/12. Okay, I'm confident. 35/12. Now we'll square root both sides. So we have now x minus 3/2 equals, and remember, don't forget, plus or minus root 35 over 12. Let's simplify this radical. Let's see, a few things we can do. First, let's split the top and the bottom, root 35 over root 12. And root 12 we can simplify, right? Since 12 is 4 times 3, that'll just be root 35 over 2 root 3. And then we need to rationalize the denominator. And to do that, we will just multiply the top and the bottom of this fraction by root 3. So now we get x minus 3 halves equals plus or minus. On the top, what is that? Let's see, that's 105. Root 105 over, that's 2 times 3, which is 6. Last step is to add 3 halves to both sides in order to isolate x. So we get 3 halves plus or minus root 105 over 6. I suppose if you wanted, you could find a common denominator here and combine these terms. Not necessarily necessary, but why not? Let's change 3 halves to 9/6 plus or minus root 105 over 6, and then we can combine these terms to get 9 plus or minus root 105 over 6. Why not? All right, one more problem. This one will be a little bit more interesting because I believe that complex numbers will come up. If I plan this correctly, let's find out. Step 1, we will move the constant term to the other side. So we have 2x squared minus x equals negative 7. Step 2, we need to make the leading coefficient 1, and we'll just divide both sides by 2 in order to do that. Divided by 2, divided by 2. So we get x squared minus, well, we can make that 1/2 x equals negative 7 halves. Okay, a little messy, but that's all right. We now need to add b over 2 squared to both sides, right? That's the key step for completing the square. We're adding b over 2 squared to both sides. Well, what's b? b is negative 1/2. So to divide a fraction by 2, you can just double the denominator. So that's negative 1/4, and if we square that, we get 1/16, right? Just to show my work here, this was negative 1/4 squared, and that gives us 1/16. So we'll add 1/16 to both sides of the equation. 1/16 equals negative 7 halves plus 1/16. All right, let's see. On the left, we'll factor, and these always, these are the easiest factoring problems you'll ever see because you just need to take b, which is negative 1/2, and cut it in half, which will be negative 1/4. So we get x minus 1/4 squared. That's how that factors. And then on the right, let's combine these fractions using a common denominator. Let's see, negative 7/12. Well, 7 times 8 is 56. So that's negative 56 over 16 plus 1 over 16. So we get negative 55 over 16. Okay? Well, we love the fact that the denominator here is 16 because that's a perfect square. Our next step here is to square root both sides, right? So on the left, just x minus 1/4. But on the right, okay, lots to think about here. First off, we can say root negative 55 over root 16. The root 16 turns into 4. And root negative 55, well, we can think about that as root 55 times root negative 1. And if you haven't already learned this, root negative 1 is defined as I. Right? So we can call this root 55I over 4. And let's think, can we simplify root 55? Well, that's 5 times 11, both prime, so no, we can't. So we're just about done. We'll add 1/4 to both sides. So we have 1/4. Oh, and I'm guilty. What did I forget to do? plus or minus. Don't forget it. So 1/4 plus or minus, and we'll write it like this, root 55 over 4i. It's nice to write complex numbers as a plus bi. So at last, that's the end of the problem and the end of the video. Thank you so much for watching, and please check out my other videos, and take care.